Assalamualaikum and a very good day to all of you. So, how are you doing in this pandemic? Hope you guys are doing well and stay healthy, stay home. So, today I'm going to teach you a lesson about motion graph. So, motion graph, we usually learn it in physics, but in mathematics subject also we learn motion graph. So, to go through to this topic, okay, so there are two types of graph that we usually use in this topic. Okay, the first one is the distance time graph, and the second one is the speed time graph. So we will look at it one by one. Okay, so the first graph that we're going to go through is the distance time graph. So judging by its name, you probably already know what are the components in the graph. So I show it to you. Okay, so the first thing that we need to know is the axis. Alright, so there are two axes in the graph. Usually there are two axes in the graph. So the first axis is the x-axis or the horizontal axis, and the second one is the y-axis or the vertical axis. Then the straight line is what we call a gradient. Okay, so the x-axis or the horizontal axis for distance time graph, it belongs to the time. While the vertical axis or the y-axis of this graph belongs to the distance. So as we can see, for every time increase, the distance of the object also increase. So this is the origin. This is the where the object starts. So there are no distance means that is the start distance, and also there are no time. So it means that the time hasn't been recorded yet. As we can see, the gradient here is moving upwards, like that, right? So there are few types of different graph that we can make from the distance time graph. Okay, so the upward graph, this shows that the speed is increasing uniformly, which means that the objects are moving with a uniform speed. Okay, like that, right? Okay, so besides this, the gradient also can be like this, which means that the gradient is moving downwards. When the gradient moving downwards, this shows that the object is going back to its original distance, okay, at a uniform speed. Okay, as we know that this gradient shows speed, right? So even though it goes downward, this shows that the object is moving backward. It's moving to its original distance, okay, or its original position. They are also described this kind of graph, which we can see that this line is perpendicular to the x-axis. This means that the object doesn't move from its initial position. Okay, so yeah, there is no speed involved because the gradient is the same. It doesn't show downward or upward. Okay. Okay, so now let's look at the questions for distance time graph. Okay, so the question is, the distance time graph shown above is Sahana's journey to her friend's house and back. Okay, so A, determine the total distance traveled, and B, value of T. Okay, here is T. Okay, if Suhana cycle with an average speed of 100 meter per minute. Okay, so let's try to solve the question. Okay, so if you are not able to okay, Okay, so let's look at the graph first. Okay, so we have a distance time graph which shows distance at the y-axis and also time in minutes in the x-axis. So distance shown is in meter. Okay, so we have 500 meters. Okay, we have t and t. So what does this numbers and alphabets means? Okay, so this 500 means that Suhana travel from zero from his original place or position until 500 meter, which means she traveled to a friend's house that 500 meter from her house. So she traveled 500 meters 500 meters at time t until time t, and then from time t to time 30 minutes. Okay, minutes. Okay, she stopped at a friend's house for around, we don't know, we need to find out the value of t. Okay, so we try to solve it later. Okay, and then she goes back to her house. Okay, there's that. So let's try to solve these questions. Okay, so let's try to solve the A questions first. Okay, so A questions ask us to find the total distance traveled by Sahana. Okay, as we can see here, from Suhana's house to her friend's house, the distance between the house is 500 meters, which means that, okay, from 0 until t, Suhana's moved 500 meters to her friend's house. So let's put 500 meters. So let's put 500 meters here. Right, so 500 meters, and then at these straight lines. So straight lines means no gradient. Gradient means it doesn't move. So the position is the same, which means that Sahana at her friend's house. For a period of time, which means that from t to 30 minutes. All right. Okay, so Sahana doesn't move, so the distance is 0. Okay, next we look at this part. Okay, Sahana, the gradient is moving downwards. Okay, when the gradient moves downwards, it means that Sahana goes back to her original position, in this case her house. Alright. Okay, so from her friend's house to Sahana's house, it takes another 500 meters because she used the same route. Okay, so it takes another 500 meters, so we put 500 here. Okay, 500, so we total out and we get 1000 meter. So Sahana has traveled 1000 meter from her home to a friend's house to back to her home. Okay, for 1000 meter, which is equivalent to 1 kilometer. So that day Sahana has traveled 1 kilometer with bicycle. Okay, so let's try to solve the B question. So the B questions asks us the value of t. Okay, so here's the relative for you guys. So as you can see, I've drawn a triangle over here and there's 3 letters in it, so D, S and T. So D stands for distance, okay, S stands for speed, and T stands for time. So why do I draw a triangle? Okay, this shows that if you want, okay, for example, if you want to find distance, okay, you can multiply S by S and T together. So if you want to find distance, you multiply S okay, So if you want to find distance, you multiply speed with time. Alright, so if you want to find either speed or time, you need to divide t with the other one. So okay, for example, if you want to find speed, okay, speed here. Okay, so what you do, you need to divide distance with time. Easy, right? Okay, in order to find time, you can divide distance with speed. Right, so here's a simple tip for you guys. That okay, so back to the questions. We need to find the value of t, which is time, when speed is 100 meter per minute. So we get speed, we get time, and also we get distance. Okay, so the t consists only this part, right? This upward gradient. Okay, so we don't mind this other part. Okay, we just focus on this part. Right, so with the tip before. Okay, so in order to find time t, okay, so we need to divide distance and speed. So we get distance over here, we get 500, so we put here 500. Alright, and then we get our speed, which is 100 meter per minute. So let's put 100 here. So we divide 500 by 100, then we get 5 minutes. So this means that Sahana moved from her house to her friend's house, which is 500 meters from her house. Okay, in 5 minutes at a speed of 100 meters per minute. Simple, right? Motion graph is easy, you know. Okay. So that's for the distance time graph. Okay, so let's look at the other graph, which is the speed time graph. Boom. Okay, so the next graph that we're going to look is the speed time graph. Okay, so unlike distance time graph, we can see that in speed time graph we have speed and time. Okay, so in the horizontal axis is the same as the distance time graph, which is it belongs to the time. Alright, okay, so at the y-axis or the vertical axis, okay, so the distance is changed with speed. Okay, it's changed with speed, and also the gradient of this graph is not speed, it's acceleration. Okay, so there's no distance in this, so where can we find distance? Alright, so for this graph, it's really special. Okay, alright, so I found dotted line. So to find distance in speed time graph, okay, so distance is here, which means the distance is the area under the graph. So for example, like this graph, okay, so it's a triangle. So in order to find the distance traveled for this object, we need to find the area of this triangle, then we get the distance. Alright, okay, before we move on to the question for speed time graph, okay, so let's see the different types of gradient or slope. Okay, alright, so this one shows in increase, the gradient is going upwards. Okay, this shows that the object is having an acceleration. Okay, so it means that from the origin, the object accelerates until this time. So until here. Alright, the object accelerates until here. Okay, so, means that the speed is increasing, alright, gradually increasing, which means that accelerate is gradually increasing. Alright, okay, so for this graph, so we see that the gradient is going down. Alright, the gradient is going down, which means that the speed is going down for every time. For one time increase, the speed decreases. So this means that the object is having a deceleration, which means that the object is slowing down, right? Okay, so for this type of graph, we can see that the line is perpendicular to the timeline, right? Okay, so in distance time graph, so this line means that the object is stopped in distance time graph, but in speed time graph, this shows that the object is moving with a constant speed, which means that the speed of the object doesn't have acceleration or deceleration, so it move uniform in a uniform speed. Alright, okay, so now let's look at question for this. Okay, so this is the example for speed time graph. Let's look at the questions. So the question said, given the speed time graph, find A, acceleration in the first 40 seconds, and B, the acceleration in the last 50 seconds. So first 40 seconds and the last 50 seconds. Okay, so we're gonna solve this. Question. Alright. Okay, so let's do this. Okay, so let's look at the first question, the A question. So the A question asks us to find the acceleration in the first 40 seconds. Alright, so here. Okay, so the acceleration, for the formula of acceleration, is the change in speed. Okay, change in speed, and then the change in time, right? Time. Okay, so let's put it in this. Okay, so from the origin, which means the speed is 0. Okay, so moving upwards, okay, acceleration, right? So the speed gain up to 30 minutes per second, so means acceleration goes up to 30 minutes per second for 40 seconds. Alright, okay, so let's put it in the formula. Alright, so change in speed, I will take the last known speed minus with the early speed. Alright, okay, so 30 minus 0. Okay, 30 minus 0, and then for the change in time, also take the last time, right? Last time minus with the original time or the initial time, right? So okay, so we have 40 minus 0. Okay, so which means that we divide 30 over 40, so we get 3.4 minutes per second or 0.75 minutes per second. Okay, so follow the questions. If we ask for fraction, so 3.4. If we ask for decimal, 0.75. But if the question doesn't state which one, either fraction or decimals, it's better to use the decimals. Alright, okay, so let's go to the B question. Alright, so B asks us the acceleration in the last 50 seconds. So where is the last 50 seconds? It's over here, which means that from time 100 seconds, right, 100 seconds to 150 seconds, it takes 50 seconds, right? So this last part is only take 50 seconds. Alright, okay, so we need to find the acceleration for this part. Alright, so as we know, the acceleration for this part, we can see that the gradient is going down, which means that the object is having a deceleration, which means that slowing down. Alright, okay, so when the question asks for acceleration, the answer must be in negative, because it is the object is decelerate, right? It's not acceleration, it's decelerate, means that the opposite of acceleration. That's why we need to have a negative answer if the question asks for acceleration, right? So okay, same formula, alright. Okay, so now let's look at the question B. So the question B asks us for the acceleration in the last 50 seconds, alright. So this one 50 seconds, the last 50 seconds from 100 seconds to 150 seconds. Okay, so the last 50 seconds for the last part. Okay, as we can see, this part is having a deceleration because the gradient is going down, right? But the question asks us for the acceleration in the last 50 seconds. So the answer must be in negative, alright, because this is a deceleration, means that the object is slowing down, but the question wants acceleration, right? So the answer must be negative, alright. Okay, so the formula is the same as the acceleration. We take the changes in time, which means that we take 150 minus with 100, okay, and also changes in the speed. So the last speed is 0, which means that it stopped, okay, and then the initial speed is 30 meter per second, right? So we get this negative 50 over 30, and we find it, and we get negative 1.667 meter per second. Okay, so it means that the objects decelerates at 1.667 meter per second. Alright. Okay, that is all for this video. Okay, I hope that you like this video and you like the way I teach you. Alright. Okay, so that's the end of our video. I hope you like it, and thank you.